Good morning, everyone. This is how I would like you to start solving a Fourier equation. Number one, we have to know the general formula. All right, we have f of t equal to a0 divided by 2 plus summation of n starting from 1 to infinity. Okay, you put a n cos of n pi t divided by l plus b n sine n pi t divided by l, but you put for me the bracket here. That is the very first thing you do. Okay, some people will distribute, they will put this here and this here. Okay, still doesn't matter. All right, now you have to know the variable. The first you have to know the coefficient. Okay, a0 equal to what? 1 over L integral from minus L to L f of t dt. That is your A0. Okay, then you go to your AN. Your AN is 1 over L from minus L to L f of t. All right, and then you have your cos of n by t over L dt. Okay, we agree that A goes with cos and B goes with sine. All right, so now we're gonna find Bn. 1 over L integral from minus L to L f of t cos, sine goes b go with cos with sine of n pi t over L dt. All right, now what is L? Okay, we have a relationship with between the period and L, so we have t equal to t equal to 2L, and then L will be equal to period divided by 2. Okay, so those are the things that you need to know about Fourier series. But now we have special case, and this special case is called even and odd function. Okay, when we talk about even function, because here we're gonna do it graphically. Okay, even function is your y, this is your x. Even function is a function which is symmetrical about y-axis. It's symmetrical or mirror image. All right, and then the odd function is a function which is symmetrical about the origin. Let's say we have something like this. Okay, for example, you have, this is 1, this is minus 1. I have a line which is like this and line like this. They are symmetrical about the origin. All right, another way you can also call it, it's symmetrical about the horizontal, but that is the tricky part, is because the way I remember it, I have horizontal is O, odd, and vertical is where I take the E, it means even. Right, when it's symmetrical about the vertical line is even. When it's symmetrical about the origin or about the horizontal, please do not say horizontal, about the origin, then is a odd function. Because when you take this, okay, when you fold it like this, all right, you'll see that this line will end up being here. Okay, you can see that they are what? They are symmetrical about the horizontal. Okay, and then when you fold it again for the second time, you see that you're gonna only have one line. Okay, good. So now we need to know the formulas. All right, we need to know the formulas. Okay, so let's say we're gonna start by even function. Even function, it goes like this. Okay, when you are in an even function, your a0 equal to what? It's equal to 2 divided by L integral from 0 to L f of t dt. All right, notice the limit is from 0 to L, and then we have 2 divided by L. All right, and then your your an is going to be 2 divided by L integral from 0 to L f of t again, but here we say a goes with cos. It's going to be cos n pi t over L dt, and then here bn equal to 0. So when you already determine that your function is even, you have full mark when you say bn equal to 0. That's it. Now okay, so now let me do my odd function. Odd function is even more simpler because your a0 equal to your an and equal to 0. So you have already 2 marks here. All right, a0 equal to 0, an equal to 0. So then here you only need one thing, bn. And then that bn, you're going to find it 2 over L integral from 0 to L f of t. And then remember we say b goes with sine, so you're going to put sine of n pi t over L, all right, dt. Okay, so you got everything that you need. But now there are some rules that you need to know. They are very, very important. Very, very important. And those rules, definitely, you can derive it, okay? For example, sine of n pi. What is sine of n pi? Let's say n equal to 0. Then I'm going to have sine of 0 pi. You know 0 pi is going to give you, it means the same thing as 0, right? And you press your calculator, your calculator is in radians. Look at that. If you do not know how to change it, you press shift and mode, and then you press 4. Okay, you are in radians. So let me press sine of 0. It's going to give me what? It's going to give me 0. Okay, now let's say n equal to 1. It's going to give me sine of pi. Sine of pi is also giving me 0. What is sine of 2 pi? I'm coming here. 2 pi is still giving me 0. Sine of 3 pi. Sine of 3 pi is still giving me 0. Sine of 4 pi is still give me 0. Sine of 100 is still give me 0. So you can derive that. You can say sine of n pi equal to 0. You see, you do not have to memorize it. You can derive it. Now we have another one which is very interesting. When you have cos of n pi, okay, equal to what? Now, let's say cos of, let's say n equal to 0, you're going to have 0 0 pi, which is 0, okay, cos of 0. And then when you press your cos of 0, it gives me 1. When you press cos of 1, it gives me minus 1. Cos of 2 pi, it gives me 1. Cos of 3 pi, it gives me minus 1. Now, I came up with this formula. This is the same as minus 1 exponent n. Minus 1 exponent n. So this is n equal to 0. So I'm gonna have minus 1 exponent 0. Any number exponent 0 give you 1. Okay, this is 1. It's gonna give me minus 1 exponent 1. Any number exponent 1 is still that number. It's gonna give me minus 1. All right, so here it's gonna give me 2 minus 1 exponent 2. All right, it's gonna give me positive 1, which is correct, the same. So that is how you derive it. All right, and here it's going to give me minus 1 exponent 3. It's going to give me minus 1. So we have this, we have that. So you don't need to memorize it. You can derive it on the spot when you're doing exam, your test. So all the best. I believe that this is very, very crucial. Once you know this, the rest is how good you are with integration. You have to know the general integration, and you need to know integration by part. And that's it. All the best. This is the basic of Fourier series, and trust me, I did this without any notes. You have to be able to reproduce this. Thank you. Bye. It was Jeremy Cantor, tutor